Hello everyone, welcome to Math 115 College Algebra. So in this section, which is section 2.6 from your textbook, we're going to learn how to solve a few different other types of equations. In fact, we're going to focus on solving some more equations using factoring, which we've already done. We're going to solve some equations that are not quite quadratic, but you can put them in a quadratic form. So something using U substitution. And then we're also going to solve absolute value equations, so equations involving absolute values. And then finally, some rational equations, which again, we've already done, but you have to be a little careful when solving rational equations. You have to make sure that the algebraic solutions that you come up with are actual solutions to the equations. And I'll explain that more carefully in a bit. Okay, so let's first look at something that we have basically already done, solving using factoring. So in this case, in this first example, I want to solve this equation using factoring. So remember, first of all, that you have to set the equation equal to 0, right? So you have to bring everything to one side. Let's bring everything to the left-hand side. So to do that, I'm going to subtract 3x squared from both sides. And I'm left with 12x to the fourth minus 3x squared is equal to 0. Okay, so now what I want to do is I want to factor the left-hand side. Well, first of all, I can pull out the greatest common factor, which in this case, like what's common to both those terms, it looks like a 3 and an x squared, right? So I can pull out a 3x squared. And I'm left with 4x squared minus 1. Okay, and again, that's equal to 0. And notice here that this second factor, this is one of our special forms. This is the difference of squares. Right, you can think of that as 2x all squared minus 1 squared, right? It's like a squared minus b squared. So it's a difference of squares. So we know that that factors into, I'll do it up here, into a, which is 2x plus b, so plus 1, times a minus b, right? And that's got to equal 0. So in this case, there's three possibilities, right? I have three factors. Each of them could equal 0. So I set each of them equal to 0. And I solve them for x. So in the first case, let me write that 0 better here. I can basically divide by 3, right? So 0 divided by 3 is still 0. And then if I take the square root of both sides, I'm going to get x is equal to 0, right? It's plus or minus 0, but that's still 0. So that's one solution, x is equal to 0. And the next one, I need to subtract 1 from both sides. And then I need to get 1x, or x by itself. Since it's being multiplied by 2, I'll divide both sides by 2. So x is equal to negative 1/2. And then finally, on the third one, I need to add 1 to both sides. And then again, I can divide both sides by 2 to get x by itself. So x is positive 1/2. So those are my three solutions. X is 0, negative 1/2, and positive 1/2. So if you want, you could check them. You could take each of these solutions and plug them back into the original equation, and you'll find that that original equation is true. Okay, for each of those solutions for x. Okay, here's another example. We want to solve. So it has 4 terms. So really, the only technique that we know when there's 4 terms, it's not even a quadratic, right? It's more complicated. It's a cubic equation, is to just try and factor by grouping, see if that works. So if we do that in this case, let me write this out. So I'm going to group the first two terms, group the second two terms. Now, again, you have to be careful. I like to write this as, let's see if I can erase that. As plus a minus 9x minus 9, right? So I can group the second two terms. Just so you don't accidentally think that you're multiplying, right? You're adding them together. Okay, now what can I pull out of that first group? Well, I can pull out an x squared, and I'm left with x plus 1. What can I pull out of the second group? So hopefully I end up with x plus 1. Well, actually, if I take out a negative 9, right, I'll be left with x plus 1. So now that x plus 1 is common to both terms, I can factor it out front. I'm left with x squared minus 9. And notice that is a difference of squares again, right? That has the form a squared minus b squared. So the x squared minus 9 can be factored into x plus 3, right? A plus b, like b is 3, a is x in this case, and then x minus 3, or a minus b. So the three possibilities are x plus 1 equals 0, x plus 3 is equal to 0, or x minus 3 is equal to 0. The first case leads to the solution x equals negative 1. The second leads to the solution x equals negative 3. And the third leads to the solution x equals positive 3. Right, so those are my solutions, right? Just three solutions in this case. Okay, so what if we don't have a quadratic equation, right? It's something more complicated. Like this next example here, this is like a quartic. It's like a degree 4 equation. But if you look closely at this, it turns out it almost has the form of a quadratic equation if we make one substitution. What we're going to do is we're going to let u, I'll write it up here, we're going to let u equal x squared. And notice that first term, right, if I square u, so that I'm going to have x squared squared, that's equal to x to the 4th, right? Remember your rules, if you have if I have x to the a all raised to the b, then the rule is I keep the base x and I multiply the exponents, a times b. So x squared raised to the 2nd power, I have to multiply 2 times 2 is 4, I get x to the 4th. So therefore I can write this now as u squared, right, because remember that is x to the 4th, minus 8, remember x squared is just u, minus 9 equals 0. So now it looks like a quadratic, right? And I can solve it in terms of u, and then eventually I'll substitute back in the x's to ultimately get my solution in terms of x's. Okay, so how do I solve this? Well, in terms of u, this is like, there's a 1 right in front of the u squared, so we can use like the BC rule, right? If I can find two things and multiply give me negative 9 and add to give negative 8, those will be the two factors that I need. So I'll write out my set of parentheses, right, for my two factors. I know the first term has to be u and u. Now I want two things and multiplied give me negative 9 and added give me negative 8. Well, negative 9 and positive 1 will work, right? If I multiply negative 9 times positive 1, that gives me negative 9. If I add those two, I'm going to get the b term, right, negative 8. So that'll work. So negative 9, positive 1. So one possibility here is that u minus 9 is equal to 0, and the other possibility is u plus 1 is equal to 0. If I solve this one, I add 9 to both sides, I'm going to get u is equal to 9. If I solve this one, I'm going to get u is equal to negative 1. But I'm not done, right? Because remember, ultimately I want my solution in terms of x's, right? So I need to go back and use that same substitution, u is x squared, and rewrite these equations now as, instead of u equals 9, I'm going to have x squared is equal to 9. And instead of u equals -1, I'm going to have x squared is equal to -1. Now to solve it, I can use the square root property. So I'll take the square root of both sides. Be careful, remember, you have to allow for the fact that it could be positive or negative. So then this is going to be x is equal to plus or minus, and square root of 9 is just 3. Right, so one solution is x is equal to -3, and the other one is x is equal to +3. And then over here, if I use the square root property, so again, I have plus or minus the square root of -1. Remember, the square root of -1 is not a real number, right? It has that special definition that we use. It's equal to, it's an imaginary number I. So this gives us the solutions x is equal to plus or minus I. So x could be -I, or x could be +I. So actually there's 4 solutions here. 2 of them happen to be real, and then 2 of them happen to be complex, or in this case there's like pure imaginary, right? Because there's no real term there. Okay, so we have our 4 solutions in this case. All right, here's another example. And it's similar. Go to the next page. So again, to solve this, we're going to do a u substitution. We're going to let u equal x squared again. So now I can write this as 3u squared, because remember, if I square u now, it's going to be x to the 4th. Right? So 3x to the 4th is the same as 3u squared, minus 2u minus 1 is equal to 0. Okay, so first I want to solve this for u. How do I do that? Well, the coefficient of the u squared term is not a 1, right? So we can try our AC rule. If I multiply a times c, I have -3. I want to think of 2 things, and multiply give me -3 and add to give me -2. Well, -3 and +1 will work. So now I rewrite that middle term, the -2u, in terms of -3 and 1. So it becomes -3u plus 1u. And then I factor by grouping, right? So what's the greatest common factor I can pull out of that first group? Well, I can pull out a 3u. And I'm left with u minus 1. And then what can I pull out of the second one to get u minus 1? Well, I already have a u minus 1, right? But effectively, there's a 1 in front, right? So really you're pulling out a 1, and you're left with u minus 1. It's already there, it's just hidden, I'm writing it explicitly. Okay, now the u minus 1 is common to both terms, so I can pull it out front. And I'm left with 3u plus 1. Okay, so one possibility, let me continue my work up here, is that u minus 1 is equal to 0. And the other possibility is 3u plus 1 is equal to 0. This one is going to give the solution, if I add 1 both sides, u is equal to 1. And this one, so I have 3u equals minus 1. I need to divide by 3. So u is equal to -1/3. Okay? But I need to solve ultimately in terms of x's, right? So now I substitute back in u is x squared. So this is really just x squared is equal to 1. And this would be x squared is equal to -1/3. Now I'm going to use the square root property. Well, the square root of 1 is just 1, right? So this first one gives us 2 solutions. X is equal to -1 and x is equal to +1. Okay, and then the second one, if I use the square root property, I'm going to have to go a little lower here. Remember, I have plus or minus in the square root of negative 1/3. So I'm going to get x equals, and then this is really plus or minus the square root of 1/3 times the square root of negative 1, right? I still have a square root of negative 1, but remember, what is that? That's I. So really, this gives the other two solutions, x equals negative square root of 1/3 I, and then x equals positive square root of 1/3 I. So those are my 4 solutions in this case. Okay, what about the next example, example 5? Well, one way of solving this one, number 5, is you could expand this out, right? I could remember this squared means x minus 5 times x minus 5. I could FOIL that out. I could distribute into negative 4, and then combine like terms, and I would just have a quadratic equation here, right? And I could solve it. But an easier way, if you recognize the form here, this is already like quadratic in form, right? If we make the substitution, u is equal to x minus 5, then I can write this as u squared minus 4u minus 21 is equal to 0. I can solve it for u, and then I'll go back and plug in x minus 5 for u, and then solve it ultimately for x. Okay, so this will probably be a little bit quicker. All right, so since I have a 1 there, I can use the BC rule. So the only way I can get u squared is u times u. Then I want two things and multiplied give me negative 21, and added give me negative 4. So negative 7 and positive 3 will work, right? So one possibility is u minus 7 is equal to 0, and the other possibility is u plus 3 is equal to 0. So this is going to give the solution u equals 7. And this will give the solution u equals negative 3. But then I have to go back in and plug in x minus 5 for u, right? So in the first case, I'm going to have x minus 5 is equal to 7. In the second case, I'm going to have x minus 5 is equal to negative 3. And if I solve this, so I'm going to add 5 to both sides, I'm going to get x is equal to 12. So that's one possibility. And then if I solve the second one, I'm going to add 5 to both sides. Negative 3 plus 5 is positive 2, so I'm going to get x is equal to 2. And those are my two solutions, right? X is 12 or x is negative 2. Okay, so again, those are like equations that were quadratic in form, right? We could make them quadratic by doing that u substitution. Okay, let's move on to another type of equation that involves absolute values. So remember what absolute value means, right? If I have, let's say I have the absolute value of a is equal to 5, right? What does that mean? Well, it means that the a could be 5, right? Because absolute value of 5 would give me 5. Or the a could be negative 5, right? Because absolute value negative 5, again, would give me positive 5. Remember, in general, the absolute value, so I'll write absolute value of a, is the distance from 0 on a real number line. So is the distance from 0 on a real number line. Right, so if you have a real number line and you're told the absolute value of a is equal to 5, then there's two possibilities, right? So 5 itself is 5 units away, right? So that works. But negative 5 is also 5 units away from 0. They're both 5 units away from 0. And absolute value just means the distance from 0, right? So they're both 5 units away. So -5 and 5 are both solutions for A in this case. Okay, so what does that mean in terms of solving absolute value equations? Well, let's just actually look at the next example to explain this. So if I have, say, absolute value of 2x minus 6 is equal to 8. Well, one possibility is this expression, which again, if you want, you can think of as A. I just called it A. A could either be positive 8 or negative 8, right? Because if A is positive 8, then the absolute value of 8 is 8. If A is negative 8, then the absolute value of negative 8 is positive 8. They're both are true. But the A here is an expression, right? So we have to account for both possibilities. We have to say either 2x minus 6, think of that as A, is equal to positive 8, or 2x minus 6 is equal to negative 8. Because both will make that absolute value equation true. Okay, and we want to figure out what x will make it true. Well, we need to solve both of these for x. So if I add 6 to both sides, I'm going to get 2x is equal to 14. And if I divide by 2, I'm going to have x is equal to 7. So that's one solution. And in here, if I add 6, I'm going to get 2x is equal to negative 2 divided by 2. So x is equal to negative 1. That's another solution. And notice, if you plugged in, here, let's actually check this, right? So if I plug in 7, I have absolute value of 2 times 7 minus 6, and I want to see whether that equals 8. Well, 2 times 7 is 14, right? So 14 minus 6 is 8. Well, the absolute value of 8 is equal to 8, right? So that checks. If I plug in negative 1, I'm just checking this, I'll put a question mark there. So this is negative 2 minus 6. Well, negative 2 minus 6, same as negative 2 plus negative 6, is negative 8. But what's the absolute value of negative 8? It's 8, right? So that checks. So those are both solutions. Okay, let's do a few more of those. Go to the next page. So in order to solve it, notice that we had to sort of isolate the absolute value piece of it, right? So that's what we'll do in this case. So let's first isolate it. So I want to get rid of that 4 first. So I need to subtract 4 from both sides. So I'm going to end up with negative 10 on the right-hand side. And then I need to get rid of the negative 3. The absolute value piece of it is being multiplied by negative 3. So to undo that, I'm going to divide by negative 3. Whatever I do to one side, do to the other side. So I'm going to end up with absolute value of x minus 5 is equal to, now it's going to be positive, right? Negative by negative is positive, 10 thirds. So there's two possibilities. Either the x minus 5, what's inside the absolute value, either that equals positive 10 thirds or it equals negative 10 thirds. And now I can solve it for x. So in the first case, I'm just going to add 5. So x is equal to 5 plus 10 thirds. Well, remember to add fractions, we need to have the same denominator. So I can rewrite the 5. Right now it's 5 over 1. If I multiply by 3 over 3, right, that'll work. So this will give me 15 thirds plus 10 thirds, which is 25 thirds. So that's one solution. And over here, again, I need to add 5 to both sides. I'm going to have x is equal to 5 minus 10 thirds. To subtract, I need to have the same denominator, so I'll multiply by 3 over 3, right? That's my factor of 1 there. And then this is, so 5 is equivalent to 15 thirds. Now I can keep the denominator, 3, and subtract the numerator. 15 minus 10 is 5. So that's the other solution. So x is 25 thirds and x is 5 thirds. Both of those will make this original equation true. If you plug both of those back in and checked it, you would find that that's true. Okay, what if the absolute value of the expression equals 0? Well, the only way that that can happen is if the expression right inside the absolute value is equal to 0, right? That's the only possibility. Absolute value of 0 is equal to 0. Nothing else will give you 0. So this, in this case, there's just one possibility. Okay, only possibility is that. And then if I solve this, I'll subtract 10 from both sides. Divide by -5. So x is equal to 2 will work, right? So if I plugged in 2 here, and you can check it, right? If I plug in a 2 for x here, I'm going to get 10 minus 10, which is 0. Absolute value 0 equals 0, right? It checks. So that is the correct solution. What if, but by the way, what if you had this? What if you had, I'll just put a star here. What if you had absolute value of 10 minus 5x is equal to -3, and you're asked to solve for that? Well, you got to be careful, right? Can an absolute value ever equal a negative value? Right? Remember, by definition, it's distance from 0. Distance is always positive, right? This can't happen. So if you get something that's like this, or if you rearrange the equation and you get this, then the answer is there's no solutions to this equation. So no solution to the equation. Because the absolute value of whatever the expression is, we'll call it a again, can't be negative. Okay, and then the last thing for these other types of equations that I want to go over is solving rational equations. We've already done some of this earlier, but we're going to do some that are a little more complicated. And when you're solving rational equations, because they involve fractions, right? Remember, rational equation is a polynomial divided by a polynomial. You have to check the solutions to make sure, basically, that you're not dividing by 0. Okay? So let me write that down here. So you must check solutions to make sure you aren't dividing by 0. Okay, because as we know, if you have anything over 0, this is undefined. Right? Mathematically, we cannot divide by 0. It doesn't mean anything. Right? It's undefined. So you would solve the rational equation like you normally would, but then you check your possible solutions to make sure that they actually solve the equation, right? That you're not, basically, so you're not dividing by 0. Okay, so for example, we'll do 2 examples of this. Let me make this a little larger here. Okay, so there's my rational equation I want to solve. I want to solve that for x. So to simplify this, I'm going to multiply both sides first by the lowest common denominator, right? I'm going to clear out all the fractions, right? All the denominators. So if I multiply by the LCD, that will work. Well, what is the LCD? Well, if I look at all the denominators, I have x minus 2 is one factor. I have an x, and then I have an x squared minus 2x. But this can be factored, this last one can be factored into x times x minus 2. Okay, So remember, to find the LCD, it's really just the LCM of the denominators. It's the lowest common multiple of the denominators. I need to take each factor the greatest number of times it occurs in each of the factorizations. So the x minus 2 occurs once in this factorization. In fact, if you want to make this symmetric, remember I could add an x here if I write x to the 0. For the second one, I could write an x minus 2 if I write it to the 0. And then the last one is just x to the 1 times x minus 2 to the 1. So if I look at the x's, I have an x to the 0, I have an x to the 1, I have an x to the 1. So what's the greatest number of times it occurs? It occurs once, right? I'm just looking for the largest exponent. So I take it once. If I look at the x minus 2 factor, here it occurs once, here it occurs 0 times, here it occurs once. So the greatest number of times is once. So I take it once. So it turns out my lowest common denominator in this case is x times x minus 2. So to clean things up, I'm going to multiply both sides of the original expression by that. Right, so I'm going to multiply the left-hand side. And the right-hand side by the LCD. And remember, x squared minus 2x is x times x minus 2, right, in factored form. So if I distribute this in, what's going to happen? Well, first of all, the x minus 2's will cancel, and I'm going to have x, and I'll just leave it like this for now, times 3x plus 2, right? But the x minus 2's cancel. Then when I multiply it by the second term, the x's will cancel, and I have a 1 times x minus 2. And on the right-hand side, the x's cancel and the x minus 2's cancel, and I just have a negative 2 left over. Okay, so let's solve this for x. So let me distribute in the x, distribute in the 1. So this is going to be 3x squared plus 2x plus x minus 2. I'm not really doing anything right when I distribute in the 1 is equal to negative 2. I'll combine like terms. Plus 3x minus 2 is equal to negative 2. And then I'm going to set it equal to 0, so I'll bring this over by adding 2. And I'm going to get 3x squared plus 3x is equal to 0. Okay, so now let's solve this for x. So go back up here. I have 3x squared plus 3x is equal to 0. So I guess I can factor out a 3x, and I'm left with x plus 1 is equal to 0. So one possibility is 3x is equal to 0, and the other possibility is x plus 1 is equal to 0. This is going to give me the solution x is equal to 0, right? I can divide by 3, so I'm just going to x equals 0. So that's a possible solution. And this is, if I subtract 1, I get x is equal to negative 1. And that's a possible solution. Now, we need to check them. Because we were dealing with rational equations, we may have divided by 0, right? So we need to check these. So let's plug the x equals 0 back in. So where I have an x, I'm going to plug in, so I'm going to write check. Check these. Okay, so where I have an x, I'm going to plug in 0. So I have 3 times 0 plus 2 over 0 minus 2 plus 1 over 0. See, we already have a problem here. And then negative 2 over 0 squared minus 2 times 0. Actually, we have two problems. See how I'm dividing by 0 here and here? I can't do that, right? So therefore, this actually was not a solution. X equals 0 is not a solution. I have to eliminate it. Now let me try plugging in x equals negative 1. So I have 3 times negative 1 plus 2 over negative 1 minus 2 plus 1 over negative 1 is equal to negative 2 over negative 1 squared minus 2 times negative 1. All right, so let's see. 3 times negative 1 is negative 3, plus 2 is negative 1. Negative 1 minus 2 is negative 3. So it looks like it's like 1/3. This is like 1 divided by negative 1 is just negative 1, right? So this is like 1/3 plus minus 1. That's going to give me negative 2/3. And then on the other side, I have, put a question mark here. I have a negative 2 in the numerator, and then negative 1 squared is 1, and then negative 2 times negative 1 is positive 2, so that's also 3. Yep, so in this case, I get negative 2/3 equals negative 2. That checks. So this is a solution. So in fact, it's the only solution in this case, right, is x equals negative 1. We eliminated the other one. Okay, so that's what I mean. You have to be careful. You have to check to see if your potential solutions are actual solutions. Okay, let's do one last one. And it's the same idea, right? So we'll start by finding the LCD. Well, the first factor is x minus 1. The second is x plus 1. The third is x squared minus 1, but that factors into x plus 1 times x minus 1, right? It's a difference of squares. So again, to find the LCD, I take each factor the greatest number of times that occurs in each factorization. Okay, I could write an x plus 1 to the 0 here, but I don't need to. Just look at, so I have x minus 1s, x plus 1s. X minus 1 occurs once here, 0 times here, once here. So I need to take it once. And then x plus 1 occurs 0 times here, once here, once here. So I need to take it once, that factor once, x plus 1. So that is my LCD, is x minus 1 times x plus 1. So now I'm going to multiply both sides by that LCD. This will allow me to clear out the fractions. And then times minus 8 over, and remember, this, if I factor it, is x plus 1 times x minus 1. Okay, so if I distribute this in the first case, the x minus 1s are going to cancel, right? And I have left negative 4x times x plus 1. I'll leave that. When I multiply by the second case, the x plus 1s will cancel, and I'm going to have plus 4 times x minus 1. And on the right-hand side, the x plus 1, x minus 1s will both cancel, and I just have a negative 8. Okay, so let me distribute, combine like terms. So I'm going to have negative 4x squared minus 4x plus 4x minus 4 is equal to negative 8. The negative 4x plus 4x, they're going to cancel. I can bring, I have to set it equal to 0, right? So I'll add 8 to both sides. So I'm going to have negative 4x squared, I guess it's plus 4, is equal to 0. And then if I factor out a negative 4, I'm left with x squared, and be careful, this would be what, a minus 1, right? Negative 4 times minus 1 will give me positive 4. Oh, and that's a difference of squares, right? So that can be factored as well. This can be factored into x plus 1, x minus 1. And if you want, you can divide both sides. You don't need that negative 4 there, right? I can divide both sides by negative 4. So really what this is saying is my possible solutions are these. Let me make a little room here. One possible solution is, well, I'm going to have x plus 1 times x minus 1 equals 0, right? 0 divided by negative 4 is still 0. So one possible solution is x plus 1 is equal to 0. The other possible solution is x minus 1 is equal to 0. This case is going to lead to x equals negative 1, so that's a possible solution. In the second case, this is going to equal to x is equal to positive 1. So that's another possible solution. So how do I know whether they're actual solutions or not? I need to check. How do I do that? I plug them into the original equation, right? So let me check the x equals negative 1 first. So I have negative 4 times negative 1 over negative 1 minus 1. That's okay. Plus 4 over, here's a problem, right? Negative 1 plus 1. And then this is also going to be a problem. If I plug in negative 1 squared minus 1. In this case, I'm dividing by 0, right? So therefore, this cannot be a solution. And if I try the positive 1, it looks like I'm going to have the same problem, right? I'm going to have negative 4 times 1. Yeah, this is a problem right here, right? That I'm dividing by 0 right there. So that can't be true, but let me just write out all these. That's okay, and then this one will also give me a problem. 1 squared minus 1 is going to be 0, right? That divided by 0, divided by 0. So this also is not a solution. So those are my two possible solutions I get algebraically, and I check both of them, and it turns out neither of them works because I'm dividing by 0. So what does that mean? It just means in this case, this equation has no solution. There's no solution for x. So this equation has no solution. There's no x that will work. Has no solution. Okay, so again, the purpose of that section was just to go over a few other types of equations that you might encounter and how to solve them. Great, thank you.